Okay, let's move on to amplitude modulation. Amplitude modulation is when one oscillator modulates the amplitude or volume of another oscillator. So what we're going to do is insert a place for this modulation to occur, which is going to be right here, connecting into our envelope. This guy is going to be our carrier, and I'm just going to name it and place it. And now we need a modulator. So the carrier is going to go into the left inlet modulator. I'm going to use another cycle. Yeah. But before we connect it, we need to do some stuff. So with this modulator, what we're going to do first and foremost is we're going to connect a float to it. Then we need to include what's called a depth of modulation. So I'm going to do a live.dial, bring up the inspector, and we'll just get mod, and this is going to be a range of 0 to 1 point. Init enable 0, and unit style is float. Has to be float. All right, let's close inspector. 0 to 1. Why is that important? Well, because we're going to be effectively scaling from 0% to 100%. And we're going to do that by creating the multiplier there, which we're then going to connect the modulator to. Next, we're going to create a plus for the audio signal. And what we're going to do here is going to be kind of interesting. I'm going to use the subtract minus 1 point, reverse subtract, sorry. So exclamation point minus 1 point here. That is going to be used to create a DC offset that keeps a constant amplitude so we don't have any volume drops out of here. If we do it without it, you'll notice some interesting stuff. Let's connect that up. And now we're not going to hear a whole lot. Why aren't we going to hear a whole lot? Well, first of all, because most importantly, I need to give this something there. And then I need to give this something there. So right now we've got a value of 0 coming out. We've got 0 to 0, and we've got 0 to 0. With 1 hertz coming through, what you hear is a pulsation. It is taking the amplitude and it's saying, okay, you know what we're going to do? We're going to pulse this. And in pulsing it, we're going to get some interesting stuff. But rather than just doing the spectroscope, let me show you how this looks. So I change it from a spectrogram, or sorry, into a spectrogram. You can see that pulsation. That is kind of cool, isn't it? And let me get another one up here to change the display axis. Where are you? Log frequency. We're going to want this on logarithmic as well. So there's our fundamental good old 440. Now watch what happens. So anything that is below the audible frequency, you get effectively a tremolo. And you can adjust the value of that tremolo. Going negative just inverts the phase, so that doesn't really matter. But let's try, 0.5. You can see it pulsing once every 2 seconds. And it's doing that by modulating the volume, the amplitude of this sine wave. Now when I get into audible range, so let's try 33.333. We start getting difference tones. You can see that together they're summing around 440. What we're actually getting is 440 minus 33.33333 and 43 or 44 plus 440 plus 33.33333, which I can control with the modulation depth. So let's get really wild. Let's add, 1024 or something. Mod depth 0, sine wave. Start bringing that in, I start getting further out. I get some interesting harmonics coming up there. It's kind of funky. Let's do factors of 440. So 440 times 2, 880, 1760 would be the next one. And let's do 3520. Was it 3520 or 3502? $35.20. All right, cool. So that gives me some interesting stuff there. I can go to town with that and just have fun. But you know what's even more fun than that? Let's get rid of those two objects and take a look at what happens. Again, let's go back to 0. Take that down. Yay, it's a sine wave. Okay, let's go back into the audible range, and guess what? It's still going to be a sine wave. Still going to pulse. But now, the difference tones have no constant amplitude. There's no constant being added. Look at how much further things separate. I get two very distinct peaks in the spectroscope. I'm still holding down 440, but now everything's lost. So let's try 440, let's try 261 on top of that. So this is giving me the classic ring modulation effect. It's a variant on amplitude modulation. Super, super, super fun. Highly recommend it. Again, your depth of modulation here, to get that, you're getting rid of this DC offset here, this plus signal and the exclamation point minus 1 point. So without that constant DC signal, you can get some really funky stuff here, as you can see. And even with it. So here's the difference, is that I've got that guy fading in, whereas opposed to if I get rid of those two and then just connect it up, I have nothing, and then I just have the ring modded outputs, the sum and the difference of the two waveform amplitudes. So that can be really useful if you want to get rid of the central frequency, then get rid of the exclamation point minus 1 point, and then the plus to get rid of that DC offset. If you want to have everything in there and be able to balance it with the mod, then leave it in. So this or that.